In everyday life, we are surrounded by many fossil-based materials. I have a pen in my hand, insulators in our buildings, and components in our vehicles. To save the planet and reduce the carbon footprint, we need to develop new bio-based alternatives. Lignin, a wood component, present in almost every plant, is a good candidate for these bio-based materials. It is separated during pulping process. However, it's mostly burned rather than being utilized. However, we found a novel perspective. We investigated potential use of lignin in many different applications, from simple fillers in polymers, functionalized materials, in 3D printing, and in more novel advanced applications, such as batteries for charge storage. In Sweden, we have more than 50 pulping factories. One factory can produce more than 50,000 tons of lignin annually. This gives Sweden a great opportunity to invest and produce lignin-based materials. Unfortunately, lignin-based materials suffer from acute brittleness, and they have a poor surface structure, almost like a writing chalk. We all know that even for the simplest application, we need materials to meet minimum mechanical properties. Even the hanger in our wardrobes, although it's not subjected to extensive force, breaks many times and we have to replace it. But we think there is a workaround to use lignin in these materials. We used a novel chemistry developed very recently known as Vitrimer. This Vitrimer chemistry not only allows us to overcome the brittleness of lignin, but also to be able to reproduce and recycle lignin-based materials simply by heating them because of this dynamic bond networks in lignin structure. We use these Vitrimers as adhesives. These adhesives not only meet the minimum industrial requirement, but also they can compete with commercially available adhesives in the market at the moment. But what about other properties of lignin? When we modify lignin chemically, most of the time it loses its intrinsic properties. Lignin is a great antioxidant and UV absorbent, and it may even preserve Vasa ship for 300 years under the sea. That's why we looked at traditions. In Greece, there is a traditional drink known as ouzo, usually served with water. When you mix water with ouzo, it starts to become cloudy and creamy, which is an indication of formation of particles in ouzo. We took this as an inspiration and started to dissolve our lignin in an organic solvent, as green as acetone and ethanol. When we start to pour water, we start to see formation of a cloudy solution. This is an indication of formation of nanoparticles from lignin. And when we look at these lignin nanoparticles under microscope, we see that not only they are uniformly spherical, but they also have a very uniform size distribution. This is very crucial in application of lignin nanoparticles in advanced nanotechnology. Nanoparticles already proved their application in our today's life. From simple application like polymers, 3D printing, water purification, and recently to more advanced applications like vaccines. So we started to develop materials based on these nanoparticles step by step. We mixed them with polymeric matrices, and we observed that not only they not negatively affect the properties of our materials, but also they improve the properties, bring antioxidant activity, and also UV resistance to our materials. And when we added them to our 3D printing resin, we observed that they will help with 3D printing by improving the resolution of final products and bringing more accuracy to the dimensions we are using, especially when we are using bio-based resins. We also mix them with more advanced organic P.PSS-like conductive polymers. And we use them to assemble a zinc battery. When we studied these zinc batteries, we learned that they actually exceeding the charge density of conventional batteries that we have. They are also easy to modify. So what we can do, we can just redisperse them in a polluted water. They will attach to microbes and pollutants. And simply by shining a blue LED light that everybody can find in a toy store, precipitate them. Now, to sum up, I presented you results from 4 last years of my PhD. The application ranges from simple fillers, adhesives, batteries, and also functional materials. Preparation of these nanoparticles is as easy as adding water to your ouzo drink. However, their potential is limitless. And we think now is the time for other researchers to join us and help us to improve the future application of these materials further. At the end, I am Mohammad Morsali. It was an honor to be here. Thank you very much. Cheers, and let's shape the future one shot at a time.